Welcome to DeepExtension. Below, I will demonstrate a step-by-step guide to model training in DeepExtension, allowing you to get started quickly. First, you need to add the base model to the DeepExtension system. We need to download the model file in advance and place it in the models subdirectory in the DeepExtension route directory. Since my local Linux system has already downloaded the model in advance, I just need to copy it here. Then we enter the base models page in the model management. Select the Add Model button and enter the page to fill in the parameters. After the addition is complete, you can see the information of the base model. If you need to deploy your model in a local Ollama environment, you need to fill in the template parameter. To obtain this parameter, you need to visit the Ollama website. Find the corresponding model page, copy the template parameter, and paste it into the DeepExtension system. Now let's upload the first dataset. With the dataset, we can start the first fine-tuning training. Here, I have chosen to upload GSM8K as the dataset for GRPO training. Click the View button to check whether the dataset content is complete and correct. Now we proceed to the first fine-tuning training task. I selected the training type as GRPO training and filled in the training name. Input selects the question field of the dataset, and output selects the answer field of the dataset. You can also refer to the Quick Start section in the official DeepExtension documentation to start your first training task. DeepExtension supports copying fine-tuning training parameters and quick submit fine-tuning training tasks. Here, I copied the first training parameters and changed max steps from 10 to 5. While waiting for training, we can add third-party models. We enter the third-party models page of Model Management and fill in the model provider, model type, model name, API key, and API address. After the test connection is passed, the inference to the third-party model can be realized in the DeepExtension system. We continue to add the deployment environment and proceed to the deployment tool configuration page in the configuration. Select Add Environment and fill in the address of the Ollama service. Currently, DeepExtension only supports the Ollama environment. We can also enter the terminal to view information about the Ollama service. For example, by entering the Ollama list command, we can view the list of models deployed by Ollama. At this point, fine-tuning training tasks have been completed. We select two training tasks simultaneously and select Training Log Comparison. You can see the comparison between the training hyperparameters and the training intermediate results. Click on Task Log to see a more complete log of the entire training process. We enter the Trained Models page of Model Management, and we can see the models. Here, I click the Save button to merge the trained model and the base model. Click the Log button to see the model saving logs. After model saving process has been completed, you can see the information of successfully saved model on the Saved Models page. Further, DeepExtension supports deploying saved models to the deployment environment we just added. Similarly, by clicking the Log button, you can see model deploying logs. After waiting for the model deployment to complete, you can see the model information that was successfully deployed on the Deployed Models page. By adding the deployed model to third-party environment, it can be inferred and evaluated. We proceed to the Deep Prompt page. DeepExtension supports inference on third-party models, deployed models, and trained models. Now, go to the Model Assessment page and create a new evaluation task. Select the Comparison Model mode and select GSM8K for the dataset. Model A selects DeepSeek Car 1 to 1.5B deployed in Ollama, and Model B selects third-party model. The user prompt variable selects the question field of the dataset, which is populated into the user prompt. Preview to see the responses of Model A and Model B in real time. Model evaluation also supports the execution of background tasks. Here, I have selected the first 5 items of the dataset for background evaluation. After the evaluation task is completed, you can view the task parameters, logs, and evaluation results.